Let's take a look at rational graphs. Rational graphs are the graphs of rational functions. So what is a rational function? The definition of a rational function is a function of the form y equals p of x over q of x, where p of x and q of x are polynomials. We're very familiar with those. And q of x cannot equal 0. So why can q of x not equal 0? That's one of the few rules in math, the few things you cannot do. You are not allowed to divide by 0. So let's look at an example so we understand this better. You just need some polynomial over another polynomial. So there's one polynomial over another polynomial. We're saying that q of x cannot equal 0, so what's the restriction here? X cannot equal the number -1/4, because that's what would make the denominator equal 0. So essentially, to get yourself a rational function, you need a variable in the denominator. We're going to look at a very specific type of rational function today. It's a rational function in transformational form. Transformational form is when you have stretches, left-right shifts, and up-down shifts. If we were to get rid of all the extra letters, the basic function would be 1 over x. So we're going to focus on that one first. If you know what that one looks like, that's great. If you're unsure, let's draw that one together. Let's pick some points. When x equals 1, we get 1 over 1, which is just 1. When x equals 2, we get 1 over 2, or a half. When x equals 3, we get 1 over 3, or a third. So if we plot those points, 1, a half, a third, I think you can see what's happening. At 4 would be a quarter, at 5 would be a fifth. Do we ever cross the x-axis? If we were to cross the x-axis, our fraction would be negative, and does that make any sense? We're putting in large positives. There's no way that becomes negative, so we just get closer and closer to the x-axis. So that means the x-axis is an asymptote. Your graph gets closer and closer to that line. I think you can see if we put negatives in front of all these, we'd end up with negative fractions. So we get the same sort of thing happening on the other side of the axis. So we get closer and closer to that asymptote. Now, what happens in between? You might be tempted to go through. Let's see if we're allowed to do that. We said the denominator can never equal 0. So x can never equal 0. X can never equal 0, that's another asymptote. You are not allowed to have an x value of 0. So do not cross the vertical asymptote. You might be able to figure out what's going on. Certainly you're not crossing it. If you're still unsure, pick some more points. When x is a half, the 1 over x function is also known as the reciprocal function. So we're taking the reciprocal of a half, which is 2. So a half goes to 2. A third would go to 3, and there we are approaching the asymptote. So the asymptote is a line that a graph approaches. So that was expected. Same thing happens on the other side. Now a much nicer version of that graph is over here. There are a couple of key points I'd like you to be aware of. This one and this one. So the point 1, 1 and the point -1, -1. So this is where the two asymptotes meet, and then we have two key points. Right one, up one, left one, down one. That'll be important when we sketch our transformations. So here's our summary. We have asymptotes at 0. We have two key points, over one, up one, left one, down one. And then the shape we have to be familiar with. Our graph will always approach the asymptotes and curve at those key points. How does that help us draw this one? First, we have to identify the shift. X minus 2 is in the denominator. When you have x minus 2 in a bracket, how does it shift? When you have x minus 2 in absolute values, how does it shift? When you have x minus 2 in square root, how does it shift? Same thing when you have x minus 2 in a denominator. I'm hoping you recognize that as the graph shifting right to. So if we go right to, our vertical asymptote is now shifted right 2. So there's our new vertical asymptote. The horizontal one has not been changed, so it stays at 0. This is where the two asymptotes meet. So a key point would be right 1, up 1, left 1, down 1. And then we approach our asymptotes. And there's our new graph. So all we're doing is taking this basic shape and just moving it up, down, left, and right. Better version of it is over here. We can check that key point over 1, up 1, left 1, down 1. And again, the key point is over from where the two asymptotes cross. Now I'm going to ask you to find the x-intercept. This is useful, it's good math skill to be able to do, and it also is going to help us check the graph. So to find an x-intercept, you take the equation, let y equal 0. To deal with a rational expression, we could multiply by the denominator. That will get rid of the denominator, and then things will be easier to see what we're doing. So those two will get eliminated, and 0 times anything is 0. So it's saying we have an x-intercept the day that 0 equals 1, which is certainly not today. In other words, there is no x-intercept. Let's check, did we ever cross the x-axis? No, we didn't, because we had an asymptote. So if you have an asymptote along the x-axis, you are expecting to have no x-intercept. Let's check the y-intercept. To find the y-intercept, you let x equal 0. So if we let that equal 0, I'm getting -1/2 for the y-intercept. Great way of checking the graph, and also useful for us to be in the habit of finding x and y intercepts. Let's try another one. What sort of shift is this? The 3 is completely separate. That would be down 3. So 1, 2, 3, down. So the horizontal asymptote is shifted down. The vertical would stay exactly where it was originally at 0. So it has not moved. Go to where the asymptotes cross. We're going to go over 1, up 1. That's where the new bend is. Go to where the asymptotes cross, left 1, down 1. And then we draw that shape where we approach the asymptotes and we bend at the key point. Approach your asymptote, bend at the key point. Beautiful. And there's our key point again. Over 1, up 1, left 1, down 1. Let's find the x-intercept. We'll let y equal 0. I'll bring the 3 over. You have a couple of ways of solving this now. Anytime you have something in the denominator, we can multiply both sides by it. We have to multiply both sides because we have to treat both sides fairly. Mathematicians are always equal on both sides. So we multiplied both sides by x. That will give us 3x equals 1. Divide both sides by 3, and we're going to get x equals 1/3. Let's check our graph and see if that's right. Yes, it is. Calculate your y-intercept. You let x equal 0. This does not look good to me. We're not allowed to divide by 0, so we have none. And we knew that ahead of time. How did we know ahead of time that we were never going to cross the y-axis? So we had a vertical asymptote at 0. Vertical asymptote at 0 says don't you dare cross that line. So we knew there was no y-intercept. Now, if you're having trouble sketching these graphs and your shape's a little off, you can always find the x-intercept and y-intercept ahead of time, and that would give you another point when you draw your graph, and perhaps that'll help you draw a better graph. Let's try this one. Ooh, 2 shifts. Right 2, because if you let x equal 2, that's what'll make that 0, and up 3. So right 2, vertical asymptote, right 2. Horizontal 1, up 3. And then we're going to draw the exact same shape we've been drawing all along. Go to where the asymptotes cross, right 1, up 1. That'll be the point where it bends. Go to where the asymptotes cross, left 1, down 1, and that'll be where the graph bends. Okay, let's look at a nicer version of that. There's our 2 key points, right 1, up 1, left 1, down 1. Let's find the x-intercept. Let y equal 0. I'm going to bring the 3 over and then multiply by the denominator. When we do that, we're going to have to multiply that out, and those we'll just get rid of. So minus 3x plus 6 equals 1. I'm going to take the negative 3 over there because I like my x's positive, and bring the 1 over here, and then divide both sides by 3. When we divide both sides by 3, we get 5 over 3 for x. So between 1 and 2 and closer to 2. There we go. All right, y-intercept, let's let x equal 0. 3 minus a half. 2.5? Perfect. All right, let's do some more. No shift left or right. So vertical asymptote remains at 0. Up 3. Horizontal asymptote up at 3. Normally what we would do, we would go right 1, up 1, and draw ourselves the graph there. We go left 1, down 1, and draw ourselves the graph there. Now, what does a negative do to a graph? I'm hoping you remember that a negative makes a graph go upside down. So instead of looking like this, our graph is actually going to look like this. If you're looking for the key point, instead of going right 1, up 1, you go right 1, down 1. So I actually missed the point of the turn. It should be a little bit higher, but I'll get this one right. So left 1, up 1. So the negative again takes your graph and flips it upside down. So there's a much nicer version of the graph. Those are our key points. And let's find the x-intercept. All right, to find the x-intercept, we'll take this to the other side, and I'm doing that again to keep as many positives as I can. And then you could multiply both sides by 3, or there's a quicker way to do this. You can take the reciprocal of both sides of the equation. And when you do that, you just get x equals 1/3. You can get to that same answer by multiplying both sides by x, but sometimes this is quicker. And there's our x equals 1/3. Let's find the y-intercept. Let x equal 0. No, we don't. And we knew we were not going to have a y-intercept because we had a vertical asymptote at 0. So no y-intercept. Let's try this one. 2x plus 1. I've got up 1 stretched by 2. Ooh, wonder how that stretch works. So up 1, vertical asymptote stays in the same place. And there's 2 ways of dealing with the stretch. For those who are really good visually, normally you go right 1, up 1, but everything is multiplied by 2. So instead of going right 1, up 1, you go right 1, up 2. So that's where the bend is. Left 1, down 1 is normal. Left 1, down 2 for us this time. And there we go. There's our graph. Now, you might be saying, I don't like this, up, down 2. There's another way to do it. Here's an easy method for you. What is your vertical asymptote? Vertical asymptote is at x equals 0. Pick a point, 1 to the left, 1 to the right. When you plug -1 in, we plug -1 in here, we get -2 plus 1, which is -1. When you plug 1 in, you get 2 plus 1, which is 3. That gives you 2 more points. -1, -1, and +1, 3. That will do exactly what I was doing when I said go right 1, up 2, left 1, down 2. So if you prefer to pick a couple of points, that's not bad. Our aim is to stop you from just picking 10 or 15 points to draw the graph. If you have to pick 2, we're okay. X-intercept. Let y equal 0. Doesn't really matter what we bring over in this case. I'm going to bring over the 1, multiply both sides by x. We'd get negative x equals 2, so x would equal -2. Check. Y-intercept, let x equal 0. I'm hoping you recognize that that's not possible. or simply skip that when you know you have a vertical asymptote at 0. Just skip doing that and go straight to none. Negative 3x plus 5. This is really time for you to start doing these on your own. Put me on pause, draw the graph, then check with me in a minute. We should have a stretch of 3. Negative flips it and moves up 5. Let's see if we can draw this. So asymptote's been moved up 5. Vertical asymptote stays at 0. Normally, right 1, up 3. But this would be down 3 because of the negative. Normally left 1. This would be up 3. So our graph should look like that. If you don't like that method of finding where the bends are, vertical asymptote is at 0, pick a point on either side and plug them in. When you plug in negative 1, you get 3 plus 5, which is 8. Plug in 1, you get negative 3 plus 5, which is 2, and you get the exact same points. Better looking version is here, and then let's find the x and y intercepts. X-intercept, let y equal 0. I would bring that to the other side so I have more positives, and then multiply by the denominator of x. When we do that, we get 3 equals 5x. Divide both sides by 5, and we get x equals 3/5. 3/5 part way to 1, looking good. Y-intercept, let x equal 0. Oh no, we didn't need to do that. We had a vertical asymptote at 0. We knew there was no y-intercept. Okay, your job today. 8 questions to do. Please practice these. We're going to be working with different sorts of rational functions, and it's important you get in your head what a transformation looks like, and then you won't get confused later on. All right, have fun.